Hello everyone. In this video here, I will be discussing another example related to Kirchhoff rules, and as usual, I'm asking you to calculate the currents through each of the three resistors in this circuit. The usual start of Kirchhoff rules, what I'll do is simply I will start distributing the current through this junction here. So I decided that this one here, I'll call it current 2 because I have resistor 2 here and it's going out. This branch here, I will have current 5 because I have resistor 5 and it's going in. For the resistor 4, I will assume current 4 is going out. So here again I4, through this one I have I2, current 2. For this branch I will have the current 5, and that's as first of all. So I can start writing my first formula, which is the junction rule. I can say simply that's current 5 equal current 2 plus current 4. The total N, which is current 5, equal the summation of the total current out, which is 2 and 4, right? Now, the second step is just to help myself remembering, wherever the current go, if it's the current going through a resistor, always going to flow from the high voltage to the low voltage. So this one will be positive side, this is the negative side, and here will be the positive, here is going to be the negative, here it's going to be the positive side of resistor 4, this is the negative side of resistor 4. For the battery, well, it's very obvious, we know which positive terminal and which is the negative terminal, but it's not going to hurt just to show them to everyone. Okay, so I know these ones. Now the second step is to define or decide where is my loop direction, where is going to be my loop direction for the circuit. So I will decide this is loop 1 and I will take it as a counter clockwise. So this is loop 1, and for the second loop also I'll take it as a counterclockwise. This is going to be my loop 2. Okay, now what I need to do is follow the voltage rules of Kirchhoff rules, from Kirchhoff rules, sorry, for the loop. So I'll start with loop 1. From loop 1, this is my side, this here, this is this square. So I'll start from the top here and I will go counterclockwise. So I'm going through the first battery. It's going to give me a positive 20 minus, going through the resistor 2 to I2. Now I'm going through battery 2, it will give me a negative 10, and coming back through resistor 4, and it's going to give me positive 4, current 4. And that's my loop. Let's simplify the circuit. It's going to be 20 minus 10, that's give me 10, minus 2I2 plus 4, current 4 equals 0. Good. So that was my first equation. This is my second equation. Now let's go to loop 2, and in loop 2 I can start from here if I want to. It's fine as long as I'm going counterclockwise as I decided. So I'm going through battery 3, and that will give me a positive 30, and going through resistor 5, and it will be minus 5I5. Now going through resistor 4, that will give me a minus 4I4. Coming back to my point here, there is nothing, so it's equal 0. That will be my third equation, which is great. This is what I need to do so far as a physics side from the solving this problem. I distributed the current through the whole circuit. I identify which current going into the junction, which current is going out of the junction. Then I followed the loop rules to generate the first loop equation and the second loop equation. Now, to solve and find out how much is the current 2, 4, and 5, we need to focus on how we're going to do that in mathematical way. Now, my way is to look at equation 2 and equation 3. I will find that there is a common current between them, which is the current number 4. It's the middle branch in the circuit. Now, I can replace I4 by just modifying the first equation. So from equation 1, I can rewrite it this way. That's the current 4 equal current 5 minus current 2. Then I will replace this value in each of these equation 2 and 3 and do the math and expand the bracket. If I do that, it will give me this thing. I can find the 10 minus 2i2 plus 4, and here's I5 minus I2 equals 0. For the equation 3, that will be 30 minus 5i5 minus 4 I5 minus I2 equals 0. All right. Now, after you do the expand and simplify your circuit, you should get these. You will get 10 minus 6i2 plus 4i current 5 equals 0. And from this one here, you will get 30 minus 9i all the current 5 plus 4 current, sorry, I think I mixed up here. It's current 2. This one here should be current 2. Okay? Alright, that equal 0. Now, once again, we're gonna just do the math. I just need to decide which one of the two currents, 2 or 5, will be eliminated. So I decided I will eliminate current 2. What do? You just multiply each equation with a certain number. So let's say I'm multiplying this with 2, and this one will be multiplied by 3. Then I will add up whatever the results. If I look carefully just to check, that's 2 minus 6, it will give me minus 12 here. And for current 2, here it's 3 times positive 4, that will give me a positive 12. Minus 12 plus 12, that will give me 0, which means it's being eliminated. Here we go. The current 2 is being eliminated. Now I'm going to do the math. 20 plus 90, that will give me 110. And here is 8 minus 27, that will give me minus 19. Current 5 equal 0. From here, current going through resistor 5 will be 5.8 ampere. From now on, it should be very easy. It's just replacing the value of whatever current we found in one of our equations. So now I have current going through resistor 5. I can just add it or replace it in one of the equations. So let's do this one. I have this equation. It's 10 minus 6 multiplied by current, the second current, plus 4 multiplied by current number 5. All right, so let's do that. It's a 10 minus 6 current going through resistor 2, 4 multiplied by 5.8 equals 0. We just do the math, and that will give us the current going through resistor 2, which is 5.53 ampere. Great. Now I have the current going through resistor 2, the current going through resistor 5. I can go back to this equation here and find the current going through resistor 4. So let's do it. Current going through resistor 4, it's current going through resistor 5 minus the current going through resistor 2, and simply it's 5.8 minus 5.53, and here we go. It will be 0.27 ampere. This is the way to find the current going through every single resistor if you're following Kirchhoff rules. Some people might use the outside frame like to make it another loop, which is okay, it's fine. For me, I prefer to split the circuit into 2 loops and keep the middle branch, like here in resistor 4, is the common between them. It will help me more to identify which one I will use to help me eliminating the equations and find my currents. Okay, I hope you found this example useful, and I'll see you again. Thank you.